Hello everyone, this is Amritpal Singh. Welcome to the next video. In my previous videos, we have talked about all the layers of CNN, like whether it's a convolutional layer, pooling layer, flattening layer, right, fully connected layer. So we discussed theoretical things about it. But today in this video, in this demonstration, I'll be showing you how we can implement the same using the Google Colab. It's basically a practical kind of a tutorial in which I'll be showing you how we can implement the same all these layers to your data set. All right, let's get started. I've already have opened up the Google Colab, you can see, and before we start, I would like to show you what's the data set we are using. So we are using a data set here which is consisting of the images of the cats and dogs. This is a data set I'm having in which it's already been classified into two parts, training and testing set, in which we have images of cats and dogs. You can see these are the cats, and the same way we are having the images of the dogs. So we have a multiple images available in this case. I've already have uploaded this data set to as a zip file in my Google Colab, in my Google Drive, from which we'll be importing the data set, right? So let's get started. So this is my Google Colab page in which I'm gonna start. Okay, very first step is to import the necessary libraries. Let's do it. I'll be importing with the help of import keyword. I'll be using TensorFlow for it. So TensorFlow as TF. Okay, this I'm using here, and I'm just running it as the cell. Okay, in second quotes and second cell, I'm gonna import another one which is Keras. So import Keras, its library for this implementation. It's all from if you're from the Python background, you already know what is TensorFlow and Keras. Let me still give you a little introduction to Keras. It's a high level API for TensorFlow, and it's providing quite a great interface for solving the machine learning problems with a focus on modern deep learning, right? That's why we're using it in our today's tutorial. Okay, so we already have imported two things. Next thing is we also be requiring now for our this for image processing, we're gonna use this one package again. It's called image data generator. Let's do it. From Keras dot tf underscore Keras dot Keras dot preprocessing dot image space import space image data generator. This is we gonna import. All right, so we have imported three important packages for this today's video, and afterwards we're gonna now start with the actual steps. For that, I'm gonna first show you where my dataset is available. I've already have uploaded on my drive. It's my Google Drive integration in which the dataset is available as the CSV file, actually sorry, the zip file. You can see this is the zip file available. So I'll be importing this from my drive only. All right, moving further, so in this case, before we start moving further, we have a image data generator available. So what is image data generator? So here I'm just referring one blog here in which you can see they has mentioned here the all the important parameters of image generator. Actually, the image data generator class is in a Keras is a powerful tool for pre-processing and augmenting the image data in a real time during the training of deep learning model. So you must be wondering what's the meaning of image augmentation. So image augmentation or data augmentation is a technique of creating new data from the existing data by applying some transformation such as flips, rotated various angles, shifts, zooms, and many more. So training the neural network on more data leads to achieving higher accuracy. That's the reason we're gonna use this image data generator class function. All right. So through which we can do a lot of transformations with the likes of translations, rotations, shearing, changes in scale, image flipping, zooming. You can see all these parameters have been mentioned here. So we'll be using exactly the same. All right, so let's do it. So in this case, what we're gonna do is we're gonna now start with the here we're gonna write here train. Any variable you can use data for data generator. I'm using this equal to. So let's do it one because I already have this variable available. Image data generator. Okay, you can see it's already coming in which we have some parameters available. Very first parameter is rescale. This you can see all the parameters have been shown here. So rescale is nothing but the feature scaling. it's for normalization. So put all the features on one scale, right? So I'm gonna do it 1 dot divided by 255. We all know that the pixel range is in within from the till the range is till 255. So we are just dividing it so that will be have on the same scale. So why we do the feature scaling? So that the data is normalized, all right? So none of the data should be given more priority. So we want the data on the same scale. That's why we're doing the feature scaling here. Okay, comma. We have a shear range. There's another parameter I've been using from this, shear range equal to 0.2. So you must be wondering what's the meaning of shear range. Actually, the shear range meaning is like it's nothing but the it's a transformation which is basically changes the orientation of object without any variation in area or volume. So we can, in simple words, we can say it's a geometrical transformation we are doing it here, right? It's called shearing, all right? So it's we can say geometric transformation. So this is called shearing, all right? Moving further, so we have given the value of it. It's all available in this, right? You can see all this ranges are available, default values. So I'm just using it from there only. Afterwards, we are just applying this zooming in or zooming out, zoom underscore range. Again, I'm just going with the default value, which is 0.2. And again, I'm going with the horizontal flip, is another transformation. So in this case, in this piece of code, we have used 3 transformation actually with the name of shear range, zoom range, and horizontal flip. So these are the 3 transformation I'm using, plus I'm using a feature scaling as well. Okay, so this is what we have done in this case. All right, this is done. Now again, I'm clicking on code button. Now afterwards, what we are gonna do is we're gonna unzip this dataset.zip into a local folder, local location of this Google Colab. All right. So what I'm gonna do is to use the unzip function. Unzip, okay, and I'm gonna use in a double quotes. I have to just give the path of this. So this I can go with it and copy path, and here I'm just pasting it. This is the path of this zip image, zip folder dataset. Afterwards -d, then I have to give the location where I'm gonna store it. So I'm gonna store it in my local location of this Google Colab. I'm gonna use user local, USR local. It's up to you, can keep it anywhere. I'm just keeping it in a user local, okay, and this is the location I'm gonna copy, and here I'm gonna paste. Okay, user local. It's up to you. You can also save in home location as well, but I'm just doing it in this user local. You can see now it has been transferring all the files into user local. Okay, you'll be getting all the data set here. You can see this been copied here. Test set and training set all are coming in. All right, it's done. Again, I'm clicking on code. Okay, afterwards, what to do? In this case, I'm gonna use training set and testing set. Okay, so here training underscore set. Okay, I'm gonna use equal to train underscore data gen 1, okay, dot flow from directory. This is, I'm gonna use this method in which I have to give the location of my data set. It's in my user local, okay, and the location is user local, then dataset / training set. Okay, this is done. Afterwards, I have to give the target size, means what will be the size of images. It's called target size. So here I'm gonna use size which is 64, because if we give the bigger size, what will happen? It will take a lot of time to process those images. So I'm gonna use 64 by 64 as a size of an image. Okay, and then I have to give batch size. What means how many images will be going in one batch. I'm just going with the default value, which is of classical value, which is 32, and then class mode is binary, because what we're going to do is we just have to predict whether the images of dog and cat, it's a binary classification. So class mode will be binary. Okay, class mode equal to binary. This is done from here. Okay, all done. I guess nothing is pending. All right, we're done. Okay, you can see found 8,000 images belonging to 2 classes. It has been resulted from this step. Moving further, In the same way, we have to go for the testing as well. Let's do it for testing as well. So test underscore data gen1 equal to the same class. I'm going to use image data generator. Okay, image data generator, and in this case I'm just gonna do only one thing, which is called rescaling. Rescale equal to 1 dot forward slash 255. Okay, just to do the feature scaling. This is done. Afterwards, next step is we're gonna do the testing part. So test underscore set1 equal to I'm gonna use test underscore data gen1. Okay, then dot flow from directory. Done. And then again I have to give the reference to my testing set. So it will be same location, user forward slash local forward slash dataset forward slash testing set. So it is called test underscore set, and here we have to give the location of the testing set, then comma, again the target size, it will be again the same, which will be 64 by 64. Okay, target size, it will be 64 by 64. I have to give 64 by 64, and then I have to give batch size, again the same, batch size will be 32. All right, this is all customizable. It's up to you which one you're gonna take. Again, the class mode will be binary. Class mode equal to binary. Okay, we are done. My training and testings are all ready. Okay, so far so good. Okay, so you can see again we've got 2000 images for the testing. All right, now let's start with our actual CNN deployment, right? So we have to define all the layers here one by one. So first of all, sorry, I have to call maybe CNN1 any variable name equal to TF, means my TensorFlow, keras, okay, dot model dot sequential. Okay, this is we're gonna initialize. Okay, this is we're gonna initialize this CNN. Okay, you can take any variable. So what is the sequential stands for? So sequential actually nothing, it groups a linear stack of layers into a model. So it's just a kind of a first step in which you're gonna now keep on adding the layers one by one with the add method. Okay, so we just have initialized this. Now let's continue. The very first layer is, we know, convolutional layer. Let's add it. So it will be CNN1 dot with the add method. Now specify here the same thing, TF TensorFlow dot keras dot layers dot, it is function is conv2d. Conv2d is a function, and inside this we have to define the filter. I hope you must be remembering what is filter. Filter is nothing but the features. Okay, let me show you from a presentation which I've just which I have presented in my video as well. So this is called features, feature detector or the filter. So we have to define the filter here. Okay, so this filter we are gonna define here. So filter is equivalent to feature map, both are same. Okay, filters I'm gonna apply, it's up to you how many filters you want to apply. I'm gonna apply 32 filters. Then kernel size it will be 3. Kernel size equal to 3. So what's a kernel size? This is a kernel size 3. Okay, 3 is a size, right? 3 by 3, it's a 3 is a size here. Kernel size equal to 3. Okay, then activation function, I've already have discussed in my videos about the activation function. It's we have a different function available like sigmoid, right? We are having ReLU, so we're gonna use the popular one, which is ReLU only. So activation function we have to define here equal to ReLU. Okay, this is a ReLU function. Now we have to define input image. Okay, input image input shape, sorry, input underscore shape. Okay, and we're gonna define equal to, because the 3-dimensional we have to define RGB, so it will be 64 and then comma. You can see it from here. The last one you can see from this is already coming in as the we can see the documentation in which everything is given. So we're gonna use the input shape 64, 64, 3. Okay, done. So we have just defined the, just a warning we can ignore, we just defined the first layer, which is called convolutional layer. Okay, we have added. Now keep on adding other layers also. The next layer we're gonna add is pooling layer. So again the same stuff, we have to use cnn1 dot add. Okay, again tf dot keras. Okay, we're gonna use max pool layer in this case, layers dot, we're gonna use max. Okay, tf dot keras dot layer, sorry I missed, layers dot max pool 2d, max pool 2d layer, and in which I have to define the pool size. I'll be letting you know what is the meaning of pool size if you forgot. Pool size equal to 2, and I have to define strides also, strides equal to 2. Okay, let me show you from the presentation. This is called as the pool size. You can see 2 by 2. Okay, and stride meaning is how you wanna shift your this square box to the next level. Stride meaning is I'm defining it 2. It means it will be going, this window will slide two places forward. Okay, this is the meaning of stride. So stride is equal to 2. This is done. So we added the convolutional layer, we have the added the max pool layer. Now we have to add another convolutional layer. So what we're gonna do is, I'm just gonna do the copy paste here. Okay, I'm just gonna do copy paste here. Let's do it. Everything will be same, just we have to change a bit here. I'm just copy pasting this content here. So here we are adding another convolutional layer. Okay, in which everything will be same, but I just want to stop it here till here. Okay, another convolutional layer added. Rest everything will be same, I guess. Yeah, done. Okay, again add the max pool layer as well. Okay, it will be just the repetition, everything will be same again. We can add it here. Okay, and run it. So far so good, right? Moving further, afterwards what we're gonna do, I'm just gonna do the flattening. So what is flattening? Converting this converting from the bigger dimension into a single dimension, so that we can put as a serve as an input to the fully connected layer. So we're gonna do the flattening. Okay, so flattening, we're gonna use again the same add method dot add, and here same stuff, tf dot keras dot layers dot flatten. Okay, that's it, nothing else. It's straightforward step. So we have applied the flattening successfully. Now moving further, now we're gonna use the fully connected layer. In this fully connected layer, we have to define, we can define with the help of dense function. Let's do it. cnn1 dot add. Okay, here we can define tf dot keras dot layers dot dense. Okay, because we have a very complex kind of problem, we have a lot of input images available, so we have to define how many neurons we want. So we have to define with the help of units equal to 128. Okay, units 128, and activation function will be ReLU. Again it will be ReLU. Okay, done. We are done with this step. Now let's define the output layer. Now let's define the output layer. For this, again it will be almost the same, but I just have to change the values of units and activation. Okay, just copy and pasting, nothing will be changed here. I have just to go with 1. It is 1 units, 1 neuron. Okay, then I have to use sigmoid function. It is recommended to use sigmoid as a part of the output layer. Sigmoid, okay, as the activation function for the output layer. So we have done with all the layers. Now what is left is we have to just now compile this CNN, and then we just have to do the check whether how much accuracy we got. Okay, and all that. This is all left now. We are just about to complete this tutorial. Now let's now do the compilation. cnn1 dot compile function, in which you have to pass the optimizer. So optimizer, it will be Adam. Okay, it's one of the commonly used optimizer, Adam. So let me little bit discuss about what's the meaning of Adam here, what this optimizer will do. So it is Adam. So let me first tell you about the Adam here. What is that? So actually this Adam optimizer is short for the adaptive movement estimation. Is a popular optimization algorithm used in training the deep learning model. So it's very quite popular in training the deep learning models. This Adam is a short form for adaptive movement estimation. All right, so we are just going with that. So Adam, and here we have to define another thing which is called loss function. So loss equal to, we have to define here loss equal to which is binary cross entropy, binary cross entropy. Okay, this is we're gonna do. So what's the meaning of this as well? So binary cross entropy, actually in the field of machine learning and data science, effectively evaluating the performance of classification model is very crucial. So binary cross entropy, which is also known as the log loss, it's one of the most widely used metrics in the binary classification task. Okay, so that's why we're using it in our tutorial as well. Okay, for evaluation. So let's go with that. So in this case, we're using binary cross entropy. Okay, which is the loss function we're gonna use. Okay, and then we have to just define the metrics. So metrics, it will be, you can use multiple matrices, but I'm just using the accuracy as a metric. Accuracy. All right, done. So far so good. So next point is, we just have to now call the fit function. So what is fit function? Again, this fit function meaning is, here we just training the CNN on the training set and evaluating on the testing set. Okay, we're gonna use fit. It's almost the end of this. So CNN 1 dot fit, and here we have to define x equal to, okay, training set. So what's my training set? It was training underscore set 1. Okay, this one, training underscore set 1. So training underscore set 1. Okay, and then we have to define validation data, validation underscore data equal to test set 1. Okay, and then we have to define number of epochs. Okay, the thing is, more the number of epochs means iteration, it'll be we can say the more will be accuracy, but because it will take a lot of time to do this epoching thing, and just so I'm just going with the 10 only, although it is recommended to at least go for 25 here so that you can get more better results. All right, because it will take time. So I'm just starting with that. It will take time. So because this epochs will take a lot of time, so I'm just going with the 10. You can see it here. It is just started. It has to do the 10 iterations here. So I'm just going for 10, but I'm recommending to go with the 25 at least, so that you can get the good results in this case. Okay. So afterwards, what is left now? Meanwhile, it is running. Afterwards, what is left is we have to import the NumPy package. It's still running. Meanwhile, we can go with the next piece of code. Import NumPy as NP. Okay, I'm just going with the NumPy here, numerical Python. Okay, as the prerequisite for my next step. Because under the NumPy, we're gonna do is we're gonna just going for prediction of the test images. Okay, it will be required. So that's why we're gonna use that. And after that, let me write it other steps as well. Okay, because the time, it will be taking a lot of time. From keras dot preprocessing import image. Okay, you can see it's going on. We just have got with the first epoch done. Now it started with the second epoch. Okay, keras dot preprocessing import image. Okay, then moving further, it's still in queue because a lot of executions are going on. That's why it's not showing as done. It's still going on, no worries. Then we're gonna go with that test image 1 equal to image dot load underscore img. We're gonna just present one image. We have to check whether that image is of dog or cat. Let's see whether my model is able to give us right result or not. Okay, So I have to give here this the path. Okay, so let me now check out from a testing set. Okay, let me give it is still going on. Okay, I'm just giving image of a cat here. Okay, copy, paste it here. Okay, the image. Okay, pasted, and then we have to give here the target size. Here only we have to give the target size underscore size. It will be again the same, 64 by 64. All right, so far so good. So let's run it. Okay, moving further. Afterwards, what to do? In this case, if you remember that when we given the image at very top, we have given 64, 64, 3. Okay, we have given this at very 64, 64 in the batch of 32, right? If you remember this one, batch size was 32. So, but now we are giving the image as the target size is 64 by 64. So we have to extend the, we have to just increase the dimension of that, so that we can also incorporate the batch. All right, because here you can see I'm just giving here the target size as 64 by 64, but I'm not including this batch. So for that I have to do what? We have to expand the dimensions. All right, so let's do that. Test image 1 equal to, okay, we have to give image. Before that we have to convert that image into the array, the numpy array, img to array test image 1, test image 1. Okay, this is important to convert. Okay, afterwards what to do? We just have to now expand the dimensions. So test underscore image 1 equal to numpy dot expand underscore dims, expand underscore dims, the test underscore dims, then test underscore image 1 comma access equal to 0. So this 0 correspond to the batch. So reason we are expanding this, so that it can be correspond to the third parameter that we given in the training. Okay, that's a point. So equal to 0. Okay, run it. So moving further, it's all in running so far. You can see we still just have reached to the fifth epoch now. That's the reason I haven't given 25, because 25 will be taking hell lot of time, right? Now last step is coming in. Now let's include this into let's suppose the variable result1 equal to cnn1 dot predict what? The test image, whether it's a dog or cat. Okay, image 1. Now last step is coming in. The last step is, here we just have to give a simple if else statement here. Like if the result is equal to 1, it will be a dog. If it's 0, it will be a cat. So last step is coming in with the if else. Here training set1 dot class indices. Okay, class indices. If the result, if the result 1, okay, 0 0 0 0 equal to 1, okay, then what? The prediction equal to dog. All right, else prediction will be cat. We are just completing this tutorial now. It will be cat. All right, and last step will be just to print the prediction. Print what? Prediction, whether because although we have given the image as cat, we have to check whether the answer is a cat or dog. It will be depending how accurately my model has taken that image, whether it is able to classify that image into cat or dog. All right, just have to wait here because the epochs are still going on. We just started with the 7th epoch here, still 3 epochs to be go. Afterward, it will be executing all these cells one by one. Then we will be ending to the coming to the last. Okay, so let me just let me just give you summary what we have done. In this case, first of all, we have imported the all the packages, the TensorFlow, Keras, and from the Keras, we have just went with the image data generator class. The image data generator class is what? Is nothing but the it's a powerful tool for the pre-processing and augmenting image. And what's image augmentation? It is actually used in the deep learning to artificially increase the diversity of the data set by applying various transformations, right? So in our example, what we have done is we just have first of all unzipping the content because we have uploaded the data into the Google Drive in a zip form, and we have applied 3 transformation and 1 scaling. Scaling is done so for normalization. We have applied shear range, zoom range, and horizontal flip. Okay, afterwards we have just prepared the training set in which we have specified the target size. I've already told you that target size should be little lesser. If it's little bigger, it will be taking a lot of time to process those images. The batch size means in one batch how many images will be processed. It is 32. The class mode binary meaning is it's a binary classification, dog or cat. Afterwards, we started with the CNN in which we keep on adding the layers. The very first layer was convolutional layer in which we have said that we'll be applying 32 filters, which is I've already shown you from the this as well. It is nothing but this is the filter. We applied 32 like this, and afterwards what we did is we just given the kernel size as 3, means 3 by 3 that matrix, and the activation function is ReLU, is one of the popular one. The input image will be 64 64 3 by 3 because it's a color image. And afterwards we have applied the max pool layer in which we have defined the pool size as 2, and strides means how many strides how many windows it will be sliding to, how many in a future direction, in the upcoming direction, how it has to slide, it means 2. And again we have applied another convolutional layer pool followed by the flattening, means converting the higher dimension into a single dimension which can be served as an input to the to our the fully connected layer. Here we have defined 128 neurons in the dense function, and we've said that the activation function is gonna be ReLU. And at last we have just also added the output layer in which the neuron will be 1 and the activation will be sigmoid. Okay, and afterwards at the end we have just tried to compile my CNN model with the Adam optimizer. What is Adam? Adam, I've told you that Adam is nothing but the it is a short for the adaptive moment estimation. It's a popular optimization algorithm used in training deep learning models, and we are going to use loss equal to binary cross entropy. The cross entropy, also known as the log loss, it's one of the most widely used metrics in binary classification task, and this metric actually help us or play a very fundamental role in training models and ensuring that they accurately distinguish between the two classes, which is dog and cat. And afterwards we use the metric as accuracy. You can also use other metrics as well as per your convenience. And afterwards we're going to use fit method. The fit method is nothing but training the CNN on training set and evaluating on the testing set. And in this case we also went with the epochs equal to 10. As I've already told you that more the number of epochs, more will be the accuracy. You can see here the accuracy has been increased from 0.666995 to the 0.7895, and you can see this loss has also been decreasing. This is the advantage of having more higher number of epochs. The only drawback is that it will be taking a lot of time to process those that epochs, the iterations. Afterwards it's still going on. We have just went with the NumPy as a package. Afterwards we are importing the image, and then we are loading up one cat image, and afterwards we are converting it into an array. And then because the target image, the target size is 64 by 64, and it's not including that the batch, so we have to kind of extend that dimension with the expand dims. Okay, and afterwards we just have just try to predict the test image, and with the help of simple if else function. And if the result 100 means if it's 1 it will be dog, otherwise it will be cat, and last we're gonna print the prediction. All right, so you can see everything has been done. So you can see whether, okay, here we have little error. Let me check out what's the error we got here. at very last, okay, it will be double equal to, sorry, it is double equal to, okay, that's why it's showing the error. Let me run the cell again. All good. Last print prediction, and answer is dog. Okay, it's showing wrong because again I'm showing I'm saying for that because of the fact the epochs is 10, it's not well trained, so we have a little error here, but it's okay. You should expect here cat if the number of epochs is maybe let's suppose 25. All right, but I hope from this tutorial you must have got an understanding that how we can apply CNN using Python or on this Google Colab. Right, thanks for watching guys, see you next video.